Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, we are going to have a look at StarVector. StarVector is a specialized vision language model designed specifically for generating scalable vector graphics or SVG code. StarVector takes visual inputs such as images and or textual descriptions and then generates corresponding SVG. SVG or Scalable Vector Graphic Code is an XML based markup language for creating two-dimensional vector graphics. If you look at the architectural diagram of this star vector, this gives you a bit more idea. Unlike raster graphics formats like JPEG or PNG, SVG files define graphics through vector commands such as points, lines, shapes, colors, curves, and text, making them resolution independent. They scale smoothly without pixelation because they are rendered mathematically rather than pixel by pixel. There are a lot of characteristics which are unique to SVG code, such as I said, they are XML based, they are defined in plain text format, and we will see shortly when we install this model star vector locally and then generate this SVG code. Their file sizes are small and that is why they load fast on web pages. They are very scalable, animatable and interactive even if you use it with JavaScript and cascading style sheet. So this star vector uses vision language model approaches where it is combining vision transformer as the image encoder with a language model adapter to generate SVG code. So now let's try to get it installed and we will see how it works. Let me also give a huge shout out to Mast Compute who are sponsoring the VM and GPU for this video. If you're looking to rent a GPU on very affordable prices, you can find the link to their website in video's description. Plus, I'm also going to give you a discount coupon code of 50%. This is my Ubuntu system and this is my GPU card, NVIDIA RTX A6000 with 48 GB of VRAM. Let's start by creating a virtual environment with Conda, and you can see I'm using Python 3.11. Also, they have released this model which is, you can see, in 8 billion. You can even go with the 1 billion if you don't have that much VRAM, but I'm just going to go with this one at the moment. And I will drop the link to it in video's description. Okay, next up, let's git clone the repo of this. And that is done. And then we need to install all the prerequisites from the root of the repo. And before that, I'm also upgrading this pip. This is going to take a couple of minutes. While that happens, let me also introduce you to the sponsors of the video, who are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will also drop the link to their website in video's description. And everything is installed. Let me now launch my Jupyter notebook. And now let's first download the model from Hugging Face. And the model is being downloaded. As you can see, there are 4 shards. And the model is now loaded onto our GPU. Let's generate some SVG code from an image. Okay, so it also gave us an error. Let's also check the error first. Okay, so we just need to install this deep speed, which is fine. It seems they haven't included it in their repo. So all you need to do is to just go at the top and then say pip install deep speed. And let's run this. Shouldn't take too long. And this time it has worked successfully. And now after downloading that star vector model, it is also downloading star coder, which primarily it uses as a LLM in order to generate the code. And now both the models are downloaded and it has also done the evaluation. Okay, now let's generate the SVG code from the image, and for that this is the inference code I'm going to use. I'm just going to use our local image. This is the image, and then from there we are simply generating the SVG code and then storing it here. So let me run this. And it has generated the code. Let's print the code. Let me run this, and there you go. This is our XML code which has come out of this image. Pretty nifty, I would say. And if you want to display back this image from the code which you have just generated, just give this code to something like IPython. Let's run this. There you go. So this is our image. So you can convert it back to the image by just using this code, and that is the beauty of it. And now let's try one more image. So I'm just going to give the path here, and then let's run it. While it runs, let's also check the VRAM consumption. Let me clear this and run it again. So it is consuming just close to 16 gig of VRAM for a 8 billion model, which is very decent. Okay, let's wait for it to come back. And by the way, it takes around I would say a minute to come back. And it has produced the code, which looks quite good in a proper XML fashion. And you can test it out by simply just converting it back to your image. There you go. Looks pretty cool. Okay, let's try one final example. And in this final one, I'm just going to go with this shape and see how it goes. And while it does that, let's talk a bit more about its, I would say, the training, because you can also not only fine tune it on your own data set, but it is quite interesting to learn about its own training, because what they have done it to train StarVector, they have created SVG stack, which is a diverse data set of 2 million samples that enables generalization across vectorization tasks and precise use of primitives like ellipses, polygons, and text. And they have addressed these challenges in SVG evaluation. That also showcases that pixel-based metrics like MCE fail to capture the unique qualities of vector graphics. They also have introduced SVG bench, which is a benchmark across 10 datasets and 3 tasks: image to SVG, text to SVG, and even diagram generation. And by using all of this StarVector has achieved state-of-the-art performance, producing more compact and semantically rich SVG, which you already have seen in the demo. And there you go, it has generated the code again. Okay, it's not that huge as previously, but anyway, let's test this out. And there you go, here is our image. Looks pretty good. So that's it. I hope that you enjoyed it. I will drop the link to it in video's description. Let me know what do you think. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.